Okay guys, it's me again, and I'm gonna do another complex. This one's a little more complicated than the previous problem, balancing a more complicated redox reaction. So in this, we're still gonna follow those same steps. So the first thing you'd want to do is assign oxidation numbers. So if you, I'm just gonna do these very quickly, but you definitely can go through and figure out what I'm doing. So really the one that I'm trying to determine is the chromium and the carbon. The hydrogens and oxygens are going to be +1 and -2. This chromium is going to be the same as its ionic charge. Oxygen's -2, so the carbon would be +4. And then you're going to want to determine what is oxidized, what's reduced. So we're going to focus in on the substances that did change in oxidation number. So we can see that the carbon goes from -2 to +4. So the carbon is being oxidized. So when I write out this oxidation, I'm going to write that whole molecule. It's ethanol, and I know it's going to undergo oxidation. So I'm going to put an arrow and then put the carbon dioxide, and then I know that it's oxidized, so I'm going to have electrons here. The reduction is going to be the chromium goes from +6 to +3. So again, when I write the reduction, I'm going to move the rules over here a little bit. I'm going to, write the dichromate ion. And I know it's going to gain some amount of electrons, and that we're going to form the chromium ion. So the next thing you're going to want to do is balance all of the elements except for hydrogen and oxygen. So you can see that we have 2 carbons that we'll need here, and then for the chromium we have 2. So we would need to have 2 over here. So now I'm ready to balance the oxygens using water. So I have over here 4 oxygens, and here I have 1 oxygen. So I need somehow to get 3 more oxygens for this oxidation reaction, half reaction. So I'm going to move this over, and I'm going to put those 3 waters right here. So now I have 3 oxygens plus 1 is 4, and here I have 4 oxygens. So I'm still doing the step over here, the step that I'm balancing oxygen using water, step number 4. For the next one, for the reduction, I'm going to move this over. And now I can see that I have 7 oxygens on the reactant side, so I'm going to want to make it so I have 7 waters on the product side. So I now have my oxygen balanced. Next step is going to be to balance the hydrogen. So on the top reaction, you can see that I have 6 hydrogens here. I have another 6 here. So I have 12 total hydrogens. So I'm going to add those 12 hydrogens to the product side. So I am now going to do Oh, I was going to balance the hydrogens. So I have 12 hydrogens over here for the oxidation on the reactant side. So I'm going to need 12 hydrogens over here. 12 hydrogen ions. Now I'm going to go down and balance the hydrogens for the reduction half reaction. You can see that I have 14 hydrogens here. So I would need to add 14 hydrogen ions to the reactant side. So again, where are these coming from? The reaction that's given in the beginning only includes the substances, the minimal substances that are being oxidized and reduced. So we're just adding the water and the acid back in to finish writing the complete half reactions, and then we're going to total them. So I just did number 5. Now I'm going to balance charge. And I want you guys to try to do it and then pause the video and then see how you did. So pause your video and try to make it so that your charges on each side of the oxidation reaction are equal. So you're gonna add your electrons in. And for the reduction, again, you're going to add the appropriate number of electrons to balance the charge so that the charge on the reactant and the product side of each half reaction are equal. So you guys try and then check your work. All right, so check and see if you got the right number of electrons. So I can just kind of talk you through it briefly. So for the oxidation reaction, the water and the ethanol are both compounds, so the charge on the left side is 0, so I want the side on the right to also add to 0. So I have the 12 hydrogens, which are positive, plus the 12 negative electrons, and that's going to add up to 0. So that's how I got 12 here. Then for the reduction, I want to start on the side over here on the product side. I have a total of +6 for the chromiums. The water is 0, so +6. So on the reactant side, I also want it to be +6, which would mean adding 6 negative electrons. Because you have +14 minus 2 is going to be +12. +12 minus 6 will give you +6. So now I'm ready for the next step, which is to multiply so that my electrons are going to cancel. You can see that I have 12 electrons in the oxidation reaction, and I want to have 12 here. So in order to do that, I would need to multiply this whole reaction by 2. So I'm going to do that, and you guys can also do that and then check. I would pause, do it, and then check your work. Okay, so you're just checking your work. We took that bottom reduction reaction and we multiplied it by 2 because we wanted to have 12 electrons. Originally we had 6, but we multiplied everything by 2. So now we have 28 hydrogens, 2 dichromate ions, 12 electrons. On the right side, we have 4 chromium plus 3s and 14 waters. So now we're ready to add. And I want you guys to try this also. We'll pause one more time. When you're adding, we know that we're going to cancel our electrons, and then we're going to simplify any like terms that will cancel out. Okay, so we cancel out the 12 electrons, and now we're ready to add everything. So this next step that I have, you wouldn't necessarily need to show this, but this is going to help, I think, for you guys to understand how we have some like terms that we can simplify. For example, we've got 28 hydrogens here and 12 here. So what we're going to do is we're going to subtract 12 hydrogens. So essentially they are now gone. Over here, subtracting 12 would give me 16. So I would, possibly cross this out and just leave this or rewrite this reaction. The other thing that we can simplify is the water. I've got 3 waters here and 14 here. So again, I'm going to subtract water, those 3 waters, from both sides. And that means these waters will be gone, and I'll end up with 11 waters on the product side. So overall, I could rewrite this then. I have the 2 dichromate ions plus 16 hydrogens plus the ethanol. We'll learn how to name that in the next unit. And then we're going to get carbon dioxide, the 4 chromium plus 3s, and 11 waters. I hope that helps as you start to balance these. They're fun, especially when you get them right. It feels good. Good luck.